Chainsys platform and the respective source and target systems. In our case, the source is SAP ECC and the target is SAP S4 HANA. This is the connection landing form where we see all the supported endpoints. Let's see how we can define an SAP connection. This is the SAP connection definition form. This is the connection we are going to use as a source connection, which is the SAP ECC instance. To connect the SAP, we connect information like hostname, system number, client name, language, pool capacity, and username and password needed to connect to the SAP system. We also have the connection for SAP S4 HANA, which is our target system. Again, we have connected information like host, system number, client name, language, pool capacity, and username and password needed to connect to the SAP system. Data object extracts data from various source systems to extractions. Let's see how SAP data object is defined. So this is a data object definition form where we can see all the basic definitions of the data objects, like whether we're going to do a full refresh or incremental extraction, and what is the full refresh mode, and whether the sync option is manual or automatic. In the source definition, we can see the actual SAP object definition. So the delivery mode is defined as JCO. The BAPI is defined to extract material master data from SAP to the BAPI. Here we see all the structures, the import and table. Under table, we have the material master structure where we are extracting all the columns from the material master. We can see on the right all the column names and the data type, length of the data type, and its description. In addition, we can define filters in a data object. So here the import fields are used as filters. These act as static filters. For example, here we've chosen from date and to date and have given some values for those fields. What happens is when we run this data object, these values are passed as filter values for these two columns and filter the records accordingly. Next we have user input definition, which allows us to define a one-time filter for the data object. Meaning, when you execute data object and haven't defined any user inputs, you'll be prompted to enter a one-item value while using it, and that value will be passed to the BAPI in real time. For example, here are the prefix and username fields selected as a one-time filter option. When one executes the object, they'll be prompted to enter the values of these two fields. Other than that, we have a custom column option where you can define additional columns that don't exist in the SAP system. It can be added as a custom constant value or a runtime user input value. We have a preprocessor which allows execution of an SQL block or stored procedure before the extraction happens. Loaders are used to load data into the target systems to define connections. Let's see how an SAP loader is defined. This is the loader definition form, where all the basic information is provided, like whether the loader supports simultaneous execution and when to run the pre-validations, if there needs to be confirmation after pre-validation or after staging. And if the batch processing mode is concurrent or sequential, and how many batches are to be executed. Next, we'll define the BAPI to load data of the material master into SAP S4 HANA. So all the structures, export or import, are shown here. We are seeing the columns of the head data structure. On the right, we can see the column names for the head data structure and its data type and whether it is unique or not. All that information is defined here. We can also have a preprocessor defined in the loader, which gets executed right before the data starts loading. It can be an SQL query, a procedure, or a data object. If you have defined a data object as a preprocessor, internally, you can consume any SOAP services, so we have the flexibility to do all of that. Then we have a transformations section where we do all the data transformations, whether it's a lookup or data sequencing. All those transformations are defined here. This is a lookup transformation defined for a material group cross-reference, so we have the cross-reference to look up the material group. So we'll be looking at the source material group, and then we're getting the corresponding target material group name and assigning it to the attribute. And then we have our own leap feature, pre-validation, which validates your data to make sure it matches the expectations of the target system before the data starts loading. For example, let's see how we are validating the material type. We've referred to the data object where we have all the values of the material types. We compare the attribute from the loader to the actual material type of your data object. If it's valid, the record will be passed. Otherwise, you get the error message saying invalid material type. After pre-validation, we have a Preload Reconciliation option, by which we can see our raw input data transform the data in the loader. Similarly, we have a post-load reconciliation, which does reconciliation after loading the data to the target system. It reconciles the transformed data we have in our loader with the actual data that got loaded to the target system. We have a post-processor. With the post-processor, you can update an SQL query or provide another loader for source update. We have custom entity options to change the structure of your loader datasets as per the given input data. Dataflow connects the data object and the loader to find the raw data and define the column mapping between the source and target systems. So let's see how material master data flow is defined. This is the data flow definition. You can see on the left we have the data object, and the output is passed through a normalizer transformation. Then its entities are mapped to the loader. So all the active transformations are taken care of at the data flow level, like normalizer, router, and joiner. So in our case, we have a data object that extracts the material master data from the SAP ECC. It outputs to one entity, but our loader accepts up to 3 different data sets. We have used the normalizer to normalize the data of one entity into 2 different entities. This is a normalizer where we have 2 collection names, head data and material description. Here we can see whatever columns are added to the head data, and here we can see columns added to the material description collection. So once it's converted as two different collections, the collections are mapped to the datasets of the loader. All the column mappings are defined in the mapper. For example, here we can see the source columns of the data object and the data source, which lists all the loader attributes. On the right side, we can see all the mapped columns. So when we execute the data flow, let's see the output. We'll search the execution screen, selecting one execution. This is the output of the data flow execution. The data object has extracted 33 records and passed them through the normalize transformation, which converted it to two different entities, each with 33 records. These records are passed through the mapper and then to the loader. If we click on the loader, we can see how the data has been processed to the target system through each step. In the summary, we can see the overview of the data loading process, like how each of the 33 records was processed successfully. Errors will show up in the chart on the right. Here we can see the potential error types, like application, cascade, constrain, formatting, and validation. When we click on the transformation, we can see the transformations defined in each data set, and the transformations done for each record. For the first one, the transformation has run for all 33 records, but for the second one, it didn't run for any records because the given condition probably wasn't matched. When we click on pre-validation, we see the pre-validations of each data set and whether they're an error or success. Everything has been processed successfully. In the Preload Reconciliation, we can see the Preload Reconciliation results, whether it's matching or mismatching. All the green boxes show that the raw and transformed data are matching. Yellow represents mismatching data. For example, here at the source base, UOM is compared to the target base UOM. The source of UOM was ST, and the target base UOM is EA, so ST is the raw input and the transformed data is EA. So wherever there's differences, they're highlighted in yellow. In data loading, we can view a summary of succeeded or errored data. In the post-load reconciliation, we can see the results as either matched or mismatched data. The Chainsys platform has a powerful reconciliation engine which consigns source and target functionality after data migration is completed. The reconciliation sources are displayed graphically in ways that make it easy to understand the data. Here we are seeing the AP invoice, the reconciliation results as far as successful record count and successful record percentage. There's also an amount-wise calculation. There's also an amount-wise chart, a loaded-wise summary, along with a graph of matches versus mismatches between the source and target systems. There's an amount-wise bar chart. We can also see charts that compare the top 10 vendor list between the source and target after data migration is completed. Thank you for watching.